Hello and welcome to the explanation of the parallel one for IOD 201. IOD 201, interpretation of data. 201 is select a single piece of data, numerical or non-numerical, from a simple data presentation. For example, a table or graph with 2 or 3 variables, a food web diagram. Okay, so first thing we do, scan the passage. Here's the title, there's some text. We've got one experiment with some text and a graph. We got one experiment number 2 with some text and a table. And then we've got our questions. Okay, so what I'm going to do is take a look at the first question. According to experiment 2, what was the corrected absorbance of the solution with a SO3 minus 2 concentration of 3.7 ppm? Okay, so what's important about this? Well, experiment 2, that's pretty important, I agree. What else? SO32 minus concentration is probably also another important piece of information. And numbers, 3.7 ppm. Now, I know that ppm means parts per million, but that's because I've been doing this for a very long time. If you didn't know what ppm meant, that's okay. You actually don't need to know what it means. You just need to know ppm, okay? And you need to know SO3 minus 2. You don't need to know what that is. You just need to be able to identify it. So there it is. Alright, so we're going to look at experiment 2. We're going to look for SO32 minus concentration of 3.7 ppm. And the last piece of information we need is, what are we looking for? Well, what was the corrected absorbance? That's what we're looking for, okay? So that's the part where we need to find. So we're looking for a corrected absorbance, and we're looking in experiment 2, SO3 minus 2 concentration of 3.7 ppm. So experiment 2, it's this one. SO32 minus 2 concentration, ppm, 3.7, corrected absorbance, 0.562. Okay. Okay, so 3.7, 0.562. 3.7 ppm, 0.562 is the corrected absorbance. Corrected absorbance, that's what we want. So 0.562 is the first response. Okay, so it's correct because in the table displaying data for experiment 2, we see that the corrected absorbance for SO3 minus 2 concentration of 3.7 ppm is 0.562. Alright, very good. Now, I'm going to let you go through and identify why these were distractors for this. So you should pause here and then identify these and then restart. Well, don't restart the video, but unpause it so you can get my explanation. Okay, so your video was paused, I hope. Now we're going to look at these other distractors. So 0.031, so let's look for that one. 0.031, that's here. Okay, that's at an SO3 minus 2 concentration of 0.2 ppm, so that's what we're going to put. Incorrect response, because 0.031 is the corrected absorbance of SO3 minus 2 concentration of 0.2 ppm. Okay, I'm going to assume that these are probably similar, so I'm going to copy and paste this. So when you do it on your own, you can do a similar thing, although we do have to change the numbers, right? Because the next one is 0.774, so we go up here and look for that. We find it here, and that's for an SO3 minus 2 concentration of 5.1 ppm. So we're going to change this to 5.1. And 0.942 is actually not on the table. It's not a response. It's close to this one, but it's not quite there. So we're going to change this one because 0.942 is not listed in the table. Okay, now sometimes when they list things like this, and it's that close, they're trying to see if we can sort of kind of guess that it's close and then use this number. So I would say that 6.2. We also want to mention that 0.941 is in the table, which is very close to 0.942. The listed concentration of SO3 minus 2, O3 minus 2 for 0.941 is 6.2, which also does not match the 3.7 ppm we were looking for. Okay? So either way, this is an incorrect response. Alright, now I'm going to have you do have you do number 2 on your own, and if you need help, there will be another video that will be able to help you, titled IOD 201 Parallel 1, Question 2.